Worms are everywhere. Over 1 billion people around the world are infected with worms that cause health problems. These worms are parasites that require a human host to survive. One of the most common parasitic worms that infects humans is a schistosome. It is found in most countries in Africa. A schistosome is a tiny flatworm or a blood fluke that lives in your bloodstream in the vessels that surround either the large intestine or the bladder. People get infected by going into fresh water where there are infected snails. Infected people who use the toilet in the fresh water will contaminate the water, helping to keep the parasite's life going. If infected people are not treated, they can experience many health problems. Some schistosomes can cause anemia and diarrhea, and in the worst cases, organ failure by damaging the liver. The health problems caused by these tiny flatworms are called schistosomiasis. Treating infected people is like assembling a clock. Without all the right gears in place, the clock won't work. There are key questions that must be answered. We need to know about the transmission. Who is infected? Where are they getting infected? Why are they getting infected? We need to know about the health problems. Who is sick? What problems do they have? Are there any other possible causes of those problems? And we need to decide who, when, and where to treat. Who needs treatment? What is the best treatment? And how can we reach all the people that need treatment? Maths can help tackle these big questions. We can put the information we have into equations and models to help us develop new ways of getting rid of these worms. Imagine that we want to treat an infected population. Not everyone is the same, but if we can find out who is similar and who is different, then we can develop strategies for different groups of people. In addition to equations and models, network graphs can help us understand how similar people are. Networks are everywhere. Imagine your friendship network. Think of who your best friends are. We can draw a link between you and your friends. We can also see who from your friends also are friends and connect them too. This web of connections has valuable information. People often are friends because they have something in common. These type of friendship networks also exist in rural villages in Africa. We can also create networks by looking at other ways that individuals are similar. To understand how people get infected, we can connect people if they are doing the same type of activity in the water, or if they are in the water at the same time of day. What is fascinating is that when we build different types of networks, no matter if you are looking at the UK or Uganda, you will find similarities in the overall shape of those networks and their mathematical properties. We can learn from your networks no matter where you are to help us solve important global health problems. Some information is easier to collect than others. We can identify where people live, if there are snails in the water, and if someone is currently infected. Yet we do not know exactly how many worms are in an infected person. We need to work with African scientists on huge studies with the latest technologies to track thousands of people as they grow older to see how their infections are changing. The gears of the clock will not work until we develop new mathematical methods to bring together the complex information we have and any new information needed on these tiny parasitic worms.